Maybe you won't be able to see the smile point as clear. I mean, this top's coleslawing. I'm going to specifically go home tonight. I'm going to show my wife that scene, even though I know it will upset her.
That's low. That's low.
That way, and I'm going to record it. I will do it for you guys.
Oh, yeah.
I will record her saying, "What is wrong with you?"
It's like, you just cackle. 390 tomorrow.
Next bucket list. Yeah, because she didn't like when I watched the movie The Human Caterpillar or Human Centipede.
Oh no! I wouldn't even watch that.
Did you see the second one?
I haven't yet. I have to wait till she's not in the house. I heard it's like weirder.
Yes.
What could possibly happen?
They don't hook 3 people, they hook up 12.
Do they really?
I think so, yeah.
Yeah, but that sounds pretty digested at the end.
Anything worth doing is worth doing right. You will be the middle. Oh, by the way, Brandon, I found some chai latte K-cups in my office. If you like that stuff.
Yeah, you go to that.
Huh? No, they're in my office here. So whenever the door is unlocked, that's fine. It's in the cabinet. Just when you walk in, it's all the way in the back corner. There's two boxes. Just take them. Oh, don't we have some crap to fix?
Yep.
I think Jake broke my code, didn't he? Simon RKT. All right. Just out of curiosity here. What'd you do? What'd you do? All right, so did something change in the code?
They just deleted it.
Yeah.
No. I mean, this worked the previous class. Are we like in a different mode where it doesn't like all these kadars and stuff like that?
That's a weird error.
Let's fix this first. So it's E1. All right, that works. E2 still works. E3. Okay. I just had to find the simplest expression that it broke on so we can trace it. Okay, so it breaks on this. So if we're looking at an if expression, then we want to create a list whose first element is the word if, well, is if exp, followed by a list whose first element is what's returned by parse expression on the car of the cooter. So not kadar. Was this the... That.
Yeah.
Who told me to change that? Oh, like I thought I was working on the other one? Okay, there we go. All right. So let's do parse Simon E1, and then let's do unparse Simon E1. So this should just give us E1. So I'll put E1 after that. All right, so there's that language. So that works. Unparse Simon for lit expressions seems to work fine. Let's do E2. And E2 works for, was that var expressions? Okay, let's do E3. And E3, okay, works for if expressions. Let's do E4. And E4 works for lambda expressions. And let's do E5 and E5. Okay, that's where it breaks down.
Well, the entire code is an error. Every single character's wrong.
I hit stop. I think it's in an infinite loop. Okay, so that's when we get down to our else, right? Well, actually, no. We didn't even do an else. Don't we need an else? Yeah, so if it's not a, it must be a app expression. Okay, well, that's a more acceptable error we have there. Okay, so let's look at this. Now let's look at parse Simon of E5 here real quick. Followed by E5. Okay. So here's parse Simon of E5. We get a list that is an app expression. All right? And that list, as a second element, contains a list whose first element of that list is a var expression. So this guy. So it's replaced that A with a var expression. Whose second element is a list containing a list. So here's a list containing a list where the first element is a lambda expression. The second element is the list containing ABC as the first element, followed by a if expression. All right, so where we're running into problems here, so if we're in our else here, we want a cons. We're going to call unparse Simon on the catter of my P expression, where the catter of that P expression we're looking at, that's the car of the cooter, right? So the cooter of this guy is that list right there. So we can actually test that. So let's do define blah to be the result of parse Simon. All right. Now we can take the catter of blah and see what that guy is. The catter of blah is the list containing, so the catter of blah is this guy basically, the result of that guy. So it's a list whose first element is a var expression. Need to delete something. All right, so we're going to call unparse Simon on the catter of that expression. Now what is this? What kind of expression is this? If we're calling unparse Simon on that, this is where we run into our error right off the bat. So if we call unparse Simon on this, what do we have? Well, we're going to call it, we're going to say, is the car of that guy, well, is it null?
No.
No. Is the car a lit expression? No. Is the car a var expression? No. Is the car an if expression? No. Is the car a lambda expression? No. Is the car something else? Yeah. So the car is something else. Why? Because the car is a list, not any one of those single words. Okay, so the car is a list, and what are we going to do with that list? We're going to cons unparse on the catter of that expression. So if we take the catter of blah, we get the lambda expression. So we've actually skipped our var expression. Does that make sense? So let's do this. This is what we had before. And I'm going to take the car of this. So we can take the car of the cutter. Actually, that's not what we want. So here's an expression followed by a list containing a list whose first element, oh, because it's an app expression. That's the issue here. We encapsulated the second part as a list. So what we need is we need the car of the cutter initially. So we're going to call unparse. Let me delete this here real quick. So we're going to unparse this on the car of the cutter. So that will get us the lit expression, right? And we're going to take that, whatever's returned by this, and we're going to cons that onto the result of mapping unparse Simon on, let's see if we get the right thing by saying the car of the, it should be C-A-D-A-D-R. Did we determine we can't call that? C-A-D-A-D-R. Yep, doesn't like it. So we need to call the car of this. And that guy gives us what? He gives us a list containing a lambda expression as the first element, an if expression. Well, that's actually part of the lambda expression. That one. And here's the second element, which is an if expression. And we're going to map across that. So we're going to map unparse Simon rather, on the car of the CDA-DR. So I'm mapping unparse Simon across this. And we can actually see that work here. So I'll map unparse Simon across that.
What does map do again?
Map applies a function to every element of a list. So what do? We applied the unparse Simon to the first element of that list, which unparses the Simon code into the original code. And then we also did the second element of that list. Does that make sense? So all our code only had one little issue in it, and that issue was our, well, besides this doesn't exist with the CAADDD, blah, blah, blah. So our one issue was this guy right here in our else. It was the car of the cutter instead of just the car of the cutter. So I should be able to call unparse Simon on parse Simon E5 and then print out E5, and I should get the same output twice. Make sense? Okay. So even though it seemed like we had a big problem, I think that, of course, obviously it was Jake's fault that I changed something up here rather than something down there, which broke the old code. But our one little stupid problem was this guy right here, where I was just testing you, obviously. But hopefully what you just saw there is how I would have gone about testing it. Rather than trying to follow this whole big long rigmarole of code, let's pull out the one little piece that's broken, and let's try some different CADDRs and things like that on it until we get the piece that we think we want. Does that make sense? It became a lot clearer when we did that for getting the right solution. So now we have a parser and we have an unparser for Simon. Why? What's the point of all that other than torture?
Never occurred to me that there was one.
Usually when we do things, even though when we're doing them, you might think I don't have a point. Don't I usually have a point in the end? Kind of surprisingly, like wow, he didn't seem like he was prepared for this, but he something kind of worked there. Go ahead, Beaker. Why do you think we need parse and unparse? What's the point of them?
Break it down to its simplest form. Figure out what it is, what it does.
Which is simpler? This?
To our eyes, that's simpler, but to the computer, it'd be the other way.
Okay, so if we're let me do it this way. Let me take out this. So here is our what's good for our eyes, right? So that's just that's this guy. So which looks simpler? That guy that I just highlighted or this guy? Easily the first one for a human being, right? Now, isn't that always the case when we deal with compilers? So a human being, we like writing Java code or C# code or Objective-C code or Scheme, right, Dane?
Not schemes.
Not Scheme, anything but Scheme. Human beings like high-level languages. Why might this be preferred? Because clearly this looks more confusing to us, right? Why might this be preferred as a data representation of we're just going to refer to this as our high-level syntax, even though they're both high-level in this thing because we're writing an interpreter, not a compiler. So compilers translate from high-level to low-level. In this case, we're kind of translating from high-level into a most differenter. I think I just invented a new one. A most differenter high-level. Got my more better, my most bestest, and now my most differenter. It's like, just when I thought you couldn't come up with anything else. What's the point? Why might this be preferred by our interpreter? Because remember, the CPU is not running this directly. We're going to teach the CPU how to run this. Go ahead.
It labels what each expression is, so we can, from there, we can determine what it can do and what it can't do.
Okay. So if let's kind of display these each. So I'm going to do a E1 and an E1. So we're just going to go back through this little exercise. Here's human code. We wrote the 5. But now, this is what it looks like in our data representation language we created. This is the parsing Simon into this. What's the advantage of this? So Beaker said, well, okay, we have, it seems more explicit. The car of this list tells us exactly what kind of animal we're dealing with, right? Rather than us having to look at this and say, what are you? This has been what are you'd. Yeah, I like that one. I'm like inventing a whole new language at the same time as I'm teaching you how to invent languages. It's multitasking, people. That's what Gus does. Man, I gotta get me a box cutter.
No. Start carrying it around.
So, somebody private messages my wife. Have him go in and get his meds checked. First, he was joking, but now we're
You
concerned.
should get like a yellow plastic suit.
I just start wearing,
People totally
I
get
start wearing biosuits to school. Like,
Carry a box.
I'm wearing it around my neck with a chain. That ain't right. All right, so with this, a human being's going to look at it and say, oh, that's a 5. No big deal, right? Okay, but when we have something like this, it's kind of been pre-looked at, pre-processed, if you will. Because we can just take this and get the carbon and say, oh, he's one of those guys. I don't have to evaluate this guy to figure out what kind of guy he is. I still have to evaluate this guy to find out what he is. All right, so that's one reason. What's another reason? What's the more important reason? The more better reason? All right. Let's decide here. I mean, these are probably going to remain the same in any language. But so these are all Simon language, right? Let's see, who else wants to have their own language? We want beaker language. So define a beaker expression 1, you're probably still going to represent 5s like 5, right? Beaker 2, probably still represent A's like A's. Okay, well now beaker has a whole different view on if statements. Correct, beaker?
Yes.
Whole different view. This is like English or Spanish. They both accomplish the same thing, but they look a lot different, right? Okay, so what is Beaker's if statement going to look like? Must look different. Let's say his if statement looks like this. We're going to have a list.
That's Spanish.
We're going to say, okay. That's not what I was going for, but now it makes sense. Okay.
Okay.
Ah. 5, 7. Right? Siete?
Yeah.
Bien. All right, so that's BE3. Define BE4. This is so good. Okay, we need to come up with a replacement for lambda. Baño. So we have bathroom expressions. So we got baño. Let's actually represent this. Let's represent this differently.
Gustavo.
K A 5, 7. Okay, like that. So, lambda expressions in Beaker start with the word baño. It's actually bano. We don't have the ya because we don't have the tilde on top, right? Do we have a better word than baño then? Because it doesn't mean the same thing.
Borough.
Huh?
Borough.
What does that mean? Donkey? Is that like that?
Yeah.
Borough? Does it mean donkey or is it?
Yeah, it means
Okay. This is recorded. All right, so we have our Borough expression. Borough. Borough. Okay, Borough expression. All right, then we have a define, BE5, and this guy is going to be followed by Borough if, start mixing languages there, A57, ABC, K, A57. Like that. Okay? So those are the equivalent 5 expressions in beaker. Okay? So beaker shows up and says, look, I'm not dealing with the silent crap. This is what real languages look like. Right? So, now, Dane's going to be upset about this. We now have to write a new parser. Great. So now, we have to define parse beaker. Parse beaker is going to be a lambda expression that takes in an expression. Expression. How do you spell that? Is it like that? No, that's not right. How do you spell expression? Expression. See, this is how you know you're becoming like juniors and seniors when you find humor in programming. You can actually tell jokes through syntax. Even Dane got that one.
That is true.
That's a good one. All right, so define parsed beaker to be a lambda expression that takes in something that is a beaker expression, where beaker expressions look like this, and parses it. Okay? So, first type of beaker expression, we'll kind of follow our thing here, is our lit expression, right? So, if we, well, first of all, we're looking at if it's null expression, then return the empty list. I forgot the cond.
It's just the same.
A lot of it's the same. Let's go through it again, though. So, null expression, return the empty list. Number expression, we want to create a list whose first element is lit exp and whose second element is our expression. Right? Otherwise, if we're looking at a symbol, expr, then we're going to create a list whose first element is a var exp followed by the expression. So far, so good. Well, now beaker starts deviating. Beaker language starts deviating. It's kind of like when you're speaking to somebody in another language and all of a sudden you hear them throwing English words in there. You know, like I'm teaching a grad course this semester, and most of the students are from like Saudi Arabia or Pakistan or India, and they're sitting there, they're talking during our break, like, you know, when they're gibberish, and every now and then you'll hear them throw in the word Java, or, you know, like certainly there's a equivalent to Java. Like in English, we say Java meaning coffee, right? And then we say Java meaning Java programming stuff, right? We use the same word, don't we? So shouldn't they replace the word Java with their name for coffee?
called Java though.
Java's the.
That'd be like if they called Windows like what if we call Windows in Pakistan? They don't do that.
A lot of them, even like Facebook doesn't translate.
Microsoft. I'm gonna look that up actually.
Sounds.
What, Facebook doesn't translate well?
Like in like Slovak, they say Facebook.
Okay.
So
What's the Slovak?
if you like went literally, it'd be Tvar Knihi.
That
Defark?
doesn't roll off the tongue quite as well.
Tvar Knihi.
Beatwark.
No, I just.
No, help me.
Tvar. It's TV.
TV, Tavar.
Yeah.
Except you can.
Tvar Knihi.
Kanihi.
Yeah.
Tavar Kanihi.
Yeah.
That's fun to say.
Doesn't roll off the
Tavar Kiwi.
tongue.
Something. Okay, so next one, we're dealing with a K expression. So if car exp is equivalent to K, then we're going to create a list. And what's this list going to look like? What's the first element of this list going to be? Well, here's the point where you get to prove to me whether or not you get where I'm going with this. If exp. The first element. What's the second element? Well, here's my, so A57. So second element is going to be parse beaker of the car of the cooter expression. Next element is going to be parse beaker of the car of the cooter of the expression. Parse beaker. See, beak is actually a slang. It's a slang dialect of beaker.
Are there programming like slangs?
I guess sort of. I mean, like every language is kind of like, when you say JavaScript, it's kind of like a slang. They took like a C-type language and said, okay, let's make this a little looser.
I was thinking like instead of system out print lines, like yo, and whatever you want.
Well, in some cases there, I usually refer to as syntactic sugar. You've heard me say that before, right? So like in Java, defining a string, you say string s equals hello. Well, that's the only object in the entire Java language that works that way. Every single other one, it uses a new keyword. In fact, you can define a string by saying string s equals new string and then pass it a string inside the parameters. But they give you some slang, if you will, for building strings more better. I still have to use more better there.
More easily.
More easilier. I like that. More easilier. Okay. And then finally, parse beaker CADDDR expression. Have I showed you list ref before? Oh, do you guys want to hate me less?
Yes. No, we're good.
Let me show you something kind of cool. So I'll define a list to be A, B, C, D. Oh, I use LST. Char-at for lists. Actually, you think instead of char-at, think of it like arrays. If a list is an array, I can get bucket 0 of my array by asking for list ref, give it the array name, and then give it the bucket you want. So up here, I would actually say list ref expression. I want the car or the cooter, right? So that's actually bucket 1. Bucket 2. Bucket 3. Like that? I thought you were going to hate me less.
We hate you for not telling us soon. You see,
I also have a long history of that.
you do.
Making you do it in the horrific way for a long time, and all of a sudden it's like, oh, by the way, here you go.
What do you mean you don't know about that?
Half of you commit
I swear,
suicide.
oh no, I made the dream.
No. I purposely want you to use cars and cooters for a while, till you understand them. But now, cars and cooters, it's more of an annoyance than the fact that you don't understand them, right? Like when you're stringing cars and cooters together, it's not that we don't get what a car is and what a cooter is. It's that, okay, I have to sit there and just like kind of think through this list and say, okay, I need to take the car, the cooter, car. Right, give me bucket 4, and then give me bucket 0 of that. All right, so understand this is the equivalent. Now, nothing was keeping you from writing this before, was it? Couldn't you have written something called list ref that took in a list and...
Lack of intelligence was keeping me from writing that.
Really? That sounds like a challenge.
I didn't want to come in contact with Scheme any more than necessary.
It's getting tough on people. Everybody take out a piece of paper.
Uh-oh.
I swear. You have to go to the bathroom or something? What's going on?
I actually do. But it's not an emergency. I could have easily held it.
Do we get some more shit or not?
Depends how long it's going to take you to write your own version of list ref.
I don't want to write one.
So nothing kept you from writing this all along.
Oh, this will be easy.
It should not be hard. So, write your own function that works like list ref. Here's a bunch of examples of list ref down here. Here, I'll throw this line up top here just so you have access to it. You can see what those examples are bringing you.
Can it be hyphenated instead of
What?
Can it be my hyphen list hyphen ref?
You can call it whatever you want.
I just don't want to get that one point wrong.
I guess that makes sense. All right, so here's the function that you're finishing. I just finished off the parentheses in there, mostly for Dane. And then here's examples of how list ref currently works. So you're writing a function that would work the same way. Oh, come on. Okay. So there's an example of what LST is, being a list A, B, C, D, and then here's the function you're finishing. And my list ref should work just like these guys work. You might need a helper function. Hint, hint.
We assume that the index won't be higher than
Yeah. You can assume that they give you a legal index. I think that's reasonable. All right. I'll be back. You have 3 minutes. You should be able to do this in 6 minutes. 5 minutes. 6 minutes. But I'll be back in a minute.
Well, yeah. If the left would be the
Well, I mean-
first call. Trending copy.
Null list equal or recursive.
Equal 0, sure.
What did you return if it's the null list?
It'll give you something real.
Exactly. That's the only time you'll hit the null.
Right.
Anybody done? I was, but not anymore. What does it even mean?
I uncoded it.
He's writing it in silent.
Oh. I gotta stretch out my hip. Do you think I can get my leg up there?
Yes.
Yeah.
I'd like to see
I think
you
I want to try.
Destroyed it.
What's up?
I almost had my camera out.
You didn't think I was gonna even get it that high, did you?
I'm impressed.
If I was wearing shorts, I could have definitely got my leg up there.
Sure, it's all the yoga.
I actually do quite a bit of stretching. Yeah.
What you done?
I mean, I'm not flexible, but I'm a lot more flexible than you'd expect me to be. There's this ledge at our club that I stretch out on like that. It's a little bit shorter than that before I go out golfing. And at the beginning of the year, I can get my right leg up pretty high, but could barely get my left leg up there. Man, now, like I had to like push up and like lift my leg up onto it. Now I can just casually walk by and just throw legs up on there. Like no big deal. I could put both my legs up there at the same time.
It's called sitting.
Everything, butt out is away from the ledge. It's called hovering.
Uses the force of his
It's totally is. You use a similar technology to what the Mars lander used for touchdown.
Use your flatulence to
Keep-
suspend you.
Ignited. Solid rocket boosters.
All right, one more minute. Should be a bunch of people done by now.
might actually work.
Especially since I told you could assume that it's a legal index.
I was gonna go ahead and do that.
You know, because if I come in here and I say list ref LST4, now it screams at me. You don't even have to do that part. I told you didn't have to do it. I told you you're going to assume it's a legal index. Now, what should I make for dinner tonight? Burgers? It doesn't sound actually that bad. I can't have the bun, though. What should I put on the burgers?
I don't know, but you should make it with a box cutter.
Oh, I know what I'm going to do. That's extra credit, Dane. I saw this thing on Food Channel the other day about this place that does burgers, and their recipe for, let's say it's a half-pound burger, a quarter pound is probably ground sirloin or something like that, but the other quarter pound is ground bacon.
Whoa.
So I'm gonna have them grind me some I'm gonna have them grind me Noisky's bacon today, and mix that with ground meat and make burgers out of
It's
it.
already the best bacon.
I don't really think so.
What is?
I like it. Don't get me wrong. I just think it's overrated. I mean, I'm not saying it's bad, but it's not bad by any stretch of the imagination. I just don't think it's really much better than like Pepperidge Farms or something.
Bacon's just good.
All right, let's have them. Come on, coleslaw. Whoop. I bet you even Dane got this one right.
No way.
Really?
I was taking the critter or something. Yeah, I was like.
All right. So it's a lambda expression. If pos equals pos 0, then do what? Car LST. Else, call my list ref, passing it cooter LST, and minus pos 1. Done. It's the whole thing.
Oh no! I forgot one thing. My brain wanted it to be on the paper.
Tyler, you're an idiot.
Just didn't get there.
Brain was it your name?
No, it's the car LST is right.
All right, so let's test this.
Wait, what is everything just minus that?
So my list ref passing at LST 0 gives us the A. My list ref LST 1 gives us the B. Two gives us the C. 3 gives us the D.
Try 4, see what happens.
If you were to put the null statement in there, would it just put it as empty list then, or whatever you put after that?
Well, you can make it work however you want.
Since technically, if you did the 4, it gets to the part where okay, the list is there's nothing in the list.
Yeah, you could do a cond and say if it's null, then display a message or something. There's other things you can do that are unimportant to us, really. That makes sense? So even though I just showed you list ref today, you could have written your own weeks and weeks and weeks ago using the exact same pattern that we've done before. Right? So why didn't you?
That would have involved writing more scheme.
It was 5 lines of code.
Too much.
Skippy, did you get this right?
I overthought it by a lot.
Most people do. That's what makes Scheme funny. So almost everything in Scheme is pretty easy, but almost everything in Scheme is easily overthinkable. We just always assume it's way more difficult than it actually is. All right. So, see, we didn't even need to use list ref built into language. We could have just written our own. Okay, so this is for our if expression. All right. Otherwise, EQV car expression is, what was it, Borough? Like that? So is it da? That's Russian, right? All right, it was Borough. Okay. So Borough is like our lambda expressions. Okay, so if we're looking at Borough, then we'll create a list. And I changed it. It was Bono, but since we couldn't do the enye, since I couldn't make an enye, that's the letter, right? Enye. See, look at that. All my high school Spanish still in there. Then I'll create a list. Lambda exp. Now, note that our Borough expression flip-flops the body and the parameter list. Make sense? It's different than this guy up here. Simon language has a lambda followed by the parameter list followed by the body. Borough, or the beaker language has Borough followed by the body followed by the parameter list. Just reordering of things. So I'm going to create a list up here where the first thing is lambda expression. The second thing is, do we have a list? Does it create another list? What's my output of this guy supposed to be? Lambda, we're going to create a lambda expression followed by a list containing the IDs and containing the body. Okay. So we have a lambda expression followed by a list. And that list is going to contain first the parameters. And where's the parameters? Here's the thing. This is bucket 0, bucket 1, bucket 2. List ref bucket 2. List ref. Yeah, I will. List ref, the expression, and then 2. Followed by list ref, expression, 1. Okay, but we're going to have to call parse beaker on a couple of these. So the body here, that's an expression, correct? What do we do with expressions? We call parse beaker on them. What, parse beaker doesn't look Spanish?
Actual beaker.
I bet you can go to Spain or Mexico and find somebody named Beaker.
Good luck.
I almost guarantee it.
Think so?
Yeah. Field trip. I like that. Is it U.S. Cellular commercial where the family in the car and they get to like the motel? It's like looks like it's like haunted or something, and they all go inside and there's a picture of these two kids up there, and then all of a sudden the lightning flashes and the two kids are standing in the middle of the room and says, "We were waiting for you," and just like all creepy and stuff, and then the guy in the back's like, "Slumber party."
What was that for?
U.S. Cellular commercial.
Oh, well, obviously.
How did I not
There's like a series of them where this guy is talking about, why switch to U.S. Cellular when getting a good signal with your old phone is so much fun. It has like the guys doing the Dukes of Hazzard thing.
Yeah. What's the Dukes of Hazzard thing?
I'm done talking to stupid people.
A lot
Okay.
of things, okay?
EQV. So what's my next guide? After Borough? App expression. So else, we must be dealing with an app expression. So if we're dealing with an app expression, we'll create a list whose first element is an app expression, whose second element is what? Well, app expression has a operator and operands. What does this guy say they should look like? It should be app expression followed by a list, where the first element of the list is the operator and the second element of the list is the operands. So I will cons parse beaker of list ref expr1. That's our operators, right? I'm going to cons that onto map parse beaker list ref expr2. Like that. And now for the finale. Parse Simon, SE5, parse beaker, BE5, there's Simon, and there's beaker. I think they are the same.
This one says K.
Which one does? Don't I check for a K expression?
List bar expression K.
Yeah, because it thinks it's simple. Didn't you do that? What? Didn't you do K?
Thought I did.
What's happening?
Did I misspell it? Maybe I misspelled K.
Go to the. I think down at the bottom there. The map or the app expression, very
Yep.
the list ref expression 0 and
Oh, yeah, it should be. Hold on, hold on. Beaker looks like this. So here's the list. The car of it, that's list ref 0, right? So bucket 0 is our operator. And then we actually need to map onto the cooter of the list. That's where we went wrong. This is not list ref. Instead, it's the cooter of the expression. Because we need it as a list.
XPR.
Huh?
XPR.
Oh. There we go. Isn't the shared thing weird? Yeah, we can do this real easily. Okay, they're not the same yet.
What about EQ?
No, that won't compare them. Just as an example, if I say equal, here we can do it this way. I think this should be the same. SE1, BE1. That gives us a true. So this is comparing lists. SE2, BE2, still true. SE3, BE3. All right, so it broke on K.
I mean, they're not the same.
But they should boil down to the same.
Yeah, but that's a literal.
Huh?
But comparing first.
Yeah. Wait.
No, here. I'll parse Simon, SE3, parse Beaker, BE3. We have a list containing an if expression, followed by a list containing a var expression and two lit expressions. A list containing an if expression, followed by, okay, that's what I didn't do. We didn't make it a list. We need to have a list for that second part. So we actually wrote this guy differently. So we have a list containing this. We need that to be followed by a list containing this, this, and this. Okay, so now we should have a true there. Okay, so now they're the same. So we just wrote our interpreter to be non-equal. SE4, SE4. I'm sorry, they're true. And then SE5. Oh, hold on. SE4. SE4. And I realize these guys down here aren't. That's true. SE5. BE5. That's false. Okay. So we need to fix up our. All right. So we're going to create a list.
I think that cons should be a list.
Yeah, I agree. Well, definitely should be a list because our output should be app expression followed by a list, where the first element of the list is the rater and the second element of the list is the rands. So the first element is this. Well, no. It needs to be a cons. Because we're going to cons this guy, which is a list, onto the list that's returned by map parse beaker on this guy, Borough. So that's the car. That's list at bucket 0. Well, I didn't write equivalent code here. Oh, because there's two parameters. This is the operator. Here's the first operand. Here's the second operand. So if I take BE5, the cdr BE5, come on, that gives me the list whose first element is this Borough thing, and whose second element is this K thing. So a list containing a list. That's fine. That's what we want. We want the cooter, and we want to map parse beaker onto the cooter of BE5, which gives us that lambda expression followed by an if expression. That looks correct. And we want to cons. Well, we don't even need to go that far. So we're going to cons whatever's returned by this, which should be the, in this case, a lit expression, right? No, which should be a var expression. So parse beaker of the, there should be a 0. Let me just steal this here real quick. Okay, there's my var expression. So that's, did I do 0? I did. So that gives me this. So that's the right thing. So this first line's correct. And I'm going to cons that onto the map of parse beaker onto the cooter of BE5. Oh, here's the problem. We're making a list out of all this. That's why they're not equal. Now they'll be equal.
What's the difference between
So that's what we are doing, right? We're creating a list where the first element is the app expression, followed by a list of the operator, followed by the operands.
I don't think that's what we did the first time.
Oh, we didn't?
The operator and the operand.
Oh, we did them as two separate things. I get it. So we're just, the problem is we're just using the wrong syntax here. Now I get what you mean by, I think we just want list instead of the cons. So you want to create a list where the first element is this guy, and the second element is whatever's returned by map here as a list, correct? And there's our true. Okay, so what's the punchline there? And I know we're out of time. We had two separate programming languages, a Simon language and a Beaker language, and they both parse to the exact same language, right? Two different syntaxes that both parse to one core language, and then we could write an interpreter for that one language. Make sense? That's the value in parsing to a common denominator. It's kind of how .NET works with their Microsoft Intermediate language. All right, we'll pick up there on Tuesday.
Oh, hey, you gotta look up Gustavo's